Yes, welcome to another video on Applied Electronics. I'll be solving quiz 1 for Petroleum Engineering Student Group B, right? So here should be Group B. Let me change here. Change for Group B. For Group B students. Now, we are going to start right away. So we have question 1. State 4 properties of a semiconductor. So this one I'm not going to talk about it. You can watch the video on this. So the solution is on the previous video which I did. So it's one of the videos. Now let's move to the next question 1B. With the aid of diagram, explain p-n junction. So this one to the same too. You go and watch the video for chemical engineering students. So quiz 1 solution for chemical engineering students. I think group B. Okay. We have question 2. State 4 types of transistors, right? So 4 types of transistors. So this one, when you talk about the 4 types of transistors, here we are talking about, this is 2A. We are talking about, for example, we have bipolar junction. Junction transistors. Then we have field effect transistors, right? That is regarded the same as FET. Then we have MOSFET, right? We have MOSFET. We have MOSFET. Then we have uni-junction transistors. So these are the 4 types of transistors that we have. Right? So we have these 4. Now, moving to question 2B. Explain how bipolar junction transistor works. So for bipolar junction transistors, this question 2 is also been solved. So the solution is in quiz 1 for refining engineering students group A. So I'll not be explaining how PNP bipolar junction transistor works. Now moving on to question 3. What is the type of transformer in figure 1? So we have, this is figure 1, right? This is our figure 1. So here, the types of transformer here, you look at the transformer, you can see here, when you look at this circuit diagram, we have the transformer, which is between the V1 and V2 here. That's where the transformer is. So you can see the ratio that we have. You can see we have 8 to 1. What that means is that you have a primary side of the transformer, which is what? In that case, is going to be a very high value. So let's say 8. And from that 8 is being reduced to 1. So if you have a transformer is having a ratio of 8 to 1, it means that this is a step down transformer, right? So you can see that from 8, which is a very high value, now it goes to 1. So the type of transformer here in 3A. We have step-down transformer. Step-down transformer. Now, question 3B. What is the maximum voltage of V1, V2, and the peak load voltage if the diode is ideal in figure 1? So here we are to find the maximum voltage of V1. So if looking at the figure 1, you can see that we have V1, right? And then we have 120 volts here, right? So this is the primary side of the transformer. So what that means is that the 120 here represent the root mean square value, right? So we can write here our root mean square value is equals to 120 for V1, right? 120 volts. So once we have the root mean square value for a voltage, that means we can calculate the maximum voltage for that particular voltage. So in that case, we have maximum voltage for V1 is going to be equals to, we know that the root mean square voltage is going to be equals to 0.70 times the maximum voltage. So this is for V1 and the maximum voltage for V12 as well. So we make maximum voltage the subject, we get root mean square value over 0.707. So we end up getting, here's 120 divided by 0.707. So we get 169.73 volts. So this is what we get for V1. Now let's get for V2, right? So to calculate for V2, now before that, there are two ways of going about it, right? You can actually first use calculate the root mean square value for V2. So let's do that. So root mean square voltage for V2 is going to be equal to using the ratio. So if you have a transformer having a ratio of 8:1, that means the root mean square value of V1 is to what? The root mean square value V2. So here we are giving the root mean square value to be 120. So I can write 8:1, then we have 120 is to root mean square value of V2. So we cross multiply. So if you cross multiply, what do we get? We get here root means square value equals to this. So it just equals 120 divided by what? 8. So we have 120 divided by 8. So that will give me 15 volts. So once we've gotten the 15 volts, which is the root mean square value for V2, now let's get the maximum voltage for V2. So in that case, we use the same formula. So we can just write maximum voltage for V2 equals to root mean square value of V2 over 0.707. So we have equals to 15 divided by 0.707. So we have 15 divided by 0.707. That will give us 21.22 volts. So we've gotten now the maximum voltages. Now, and then we are also asked to find the peak load voltage. So the peak load voltage. Okay. So if we now have we can now indicate our instantaneous voltage for V2. We know it's going to be equals to maximum voltage V2 sine theta. Our maximum voltage, which is now 21.22 volts sine theta. So this is our instantaneous voltage V2. Now to get the peak load voltage, so what that means, you now have this V2 instantaneous voltage. Now if we have what forward biasing, meaning current is going to flow through the load, and then reverse biasing, there's not going to be any current, so the current flow will be zero. But we are going to indicate our alternating voltage from the equation we know here. I can indicate here to be 21.22. Here is our input. V2 in volts. Then we have here to be pi, 2 pi, 3 pi, and then 4 pi. So this is our. So with this, we can now sketch the phase alternation, right? Then we have here minus 21.22. Then we have the second cycle. Then we have the last one. So this is our alternating waveform for V2. Now, when it comes to the calculating the load, the peak load voltage. So what that means that, so the first alternation, that is going to be 0. So the first alternation, which is going to be from 0 to pi. So we have 0, like that, to pi. That means we are going to have forward biasing. So when you have forward biasing, that means the forward voltage is going to be equals to, let me use for instantaneous, we are using instantaneous. So let me use small f here, will be equals to the voltage supply over what the load resistance based on the circuit diagram that we have here. So if you have forward biasing taking place, have this. We know V, that is here we have V2. V2 is what? 21.22 sine theta over RL here is giving us 680. So we have 680. So 21 divided by 680. That will give us 31.2 milli. Or let me just, 31.2 milli sine theta. So you can see here our maximum voltage. Or in that case, our peak, we're interested in peak load voltage, right? So now we've gotten, this will be the one, our peak load current. So to get the peak load voltage, that means we are now going to calculate the load voltage, which is the voltage across the load resistor, and it's going to be equals to So instantaneous current times that of what? The resistance. So when we do this, we are having 3.2 times 10 to the power minus 3 sine theta, then times 680, right? So you see that you get back to what? The same 21.22 sine theta. Get this one. So the peak load voltage Vm is going to be equals to 21.22 sine theta. Yeah. And it's going to be 21.22 volts. We have this. So even if, yes, because you can even see you can even analyze it this way. You have V2 because here it's only one resistor, meaning the voltage supply is the same as the voltage across the load resistor. So that's where we end up getting this. Now we have to sketch the output voltage for 2 cycles. So the output voltage for this output voltage, we are here VL, the load voltage in volts. So it's going to be volts here minus 21.22. Okay, so remember this is for what? The range 0 and then pi. So that's where we have forward bias taking place. And then when we have the next alternate, which is pi 2, when we have pi, if you have pi, which is pi, and then 2 pi, that range. Here we are going to have a forward biasing because we have a negative alternation. So the forward current is going to 0. As a result, the load resistance or the load voltage is also going to be 0. Right. So we can see here we just have only this one nation. So this part will be 0. Then this one will be the same as it's also positive alternation. So it will be there will be forward biasing. Then the last one will also be 0 as well. So we get this for 2 cycles. Okay. So we've come to the end of this video. See you in the next video. Bye bye.